The objective of this lesson is to look at the last case we can use the law of signs for, which is called the ambiguous case of the law of signs. It's because there's a possibility when we're given information that you might not get any solution to the problem, you might get one solution to the problem, or you might get two. And why there is this possibility is because it's in the case of when you're given side-side angle. Now, side-side angle, if you recall from geometry, this does not lead to a specific triangle. In fact, in proofs, we can't use side-side angle because it's not a definite triangle. When you have a non-included angle, the angle is not between the two sides. So in a triangle, if you're given a triangle, two sides, and the angle's not between the two of them, that could be a number of possibilities for what the triangle could be. So in the case of solving for triangles, we need to be trying all the possibilities, and our objective here is to come up with a strategic way to find out if there's no solution, if there's one solution, or if there's two. So the warning is you may find one solution, two solutions, or no solution. All right, so let's take a look at what that looks like in these problems. What I'd like to do is illustrate it with looking at this possible triangle. Notice that if this is the angle given to you and this side is given, all right, but this other side is unknown. We don't know what this side is. We just know the direction because of the angle. The angle sets the direction for it, but we don't know how long this side is. Okay, so if we're given the other side opposite it over here, side B, it could be some different possibilities. So first of all, let's look if it's a really short side. So if this side is given to you as being really short, if I connect it up here and say, does it actually create another triangle? Notice that when it swings here, it can never hit that other side. So we have the possibility of when we have an angle here given to us and a side given to us and another side that's opposite that angle, we'll call this little b, is too short, there would be no solution. So that's one possibility. Now, what if instead we were given a length of sides here that's really long? So let's go to this one, okay, really long side to it. So when I swing this side here, it hits, and it hits right over here and gives me a side there. But when I swing it further, it never hits the side again. So this ray, it hits there, but never on the other part. That gives me a really long side here. So if I'm given this angle, so this angle's given here, and then I'm given a really long side here, so we'll call this A, and B is very long, that gives me one solution. That's a possibility too. Another possibility for one solution is what if we're given a length of side here, okay, and this length of side, when you swing it, it comes down and hits it at a right angle, like right here, and so we get a right angle. It just happens to be the exact size for a right angle, and so we get a right triangle. So another idea for one solution would be as if you're given this one, and it forms a right angle with that side. So that's the possibility to get one solution. Now let's look at what happens if we get more than one. Okay, there is a possibility that if we take a length here, this length here, and when we swing this side here, it hits it once here, okay, so right there, and then it also swings by and hits over here as well. There's two places this side hits, forming two different triangles, two different lengths there. So the possibility would be for this one is if I get a triangle that looks like this with the angle, and here's one side, so this would be A and this would be B, and you get this side listed right there. That's one possibility. And the other possibility is, what about if we swing it over and it comes to that side with the same length? So we'd have the angle given to us, and then this length here, this would be B, is shorter, and so we would get two solutions, two different possible triangles based on how long that side B is given to you. So these are possibilities we have to explore. We have to look at how we can organize our thoughts and our work to find that. So let's look at the different cases. This is going to be organized in terms of what that side is given to you. The side opposite that's swinging, is that side going to be the longest, equal to the other side? So one other possibility here for equal is if we get this side here and this side here are both equal, so A and B are equal, that's going to give me just one answer because it's going to be an isosceles triangle. So that would be one solution. So side opposite is the longest. That possibility, you're only going to get one solution. That would be if we have this possibility here where it swings and it doesn't hit on the other side. If the sides are equal here, okay, these two sides are equal with that angle, if you're given an acute angle like this, you're going to get one solution. Now, what if that given angle here, that given angle is a right angle, when that B swings over, it will never hit the opposite side. Or if it's an obtuse angle, if you're given the original angle being obtuse, that B is going to be too short to actually hit the other side. So if you're given either a right angle or an obtuse angle and the two sides are equal, these two, you're going to have no solution. That's a possibility. Now these become self-evident just from the information given to you. So these you can just work through, use the law of sines, and you'll get your solution. But what we're interested in is what happens when you have the opposite side, the shortest, where you might get this situation, or you might get these two situations here, or the possibility, again, if you get this one solution here, if it's the shortest side, where it just swings and hits it once. So here you possibly could get no solution. You could possibly get one solution, or you could get two solutions. This is the one we're going to explore with our different examples down here. So if there is a possibility of having two solutions, if you're in that situation where you're examining, is there a second solution to this problem? What you do is you're going to check the original angle, you're going to find the supplement. So it will be the supplement here. So what that means is we're going to take 180 minus the original angle. The original solved angle. So I'm going to put here this 180 minus the solved angle. That first angle you get, the original one you get, if you find its supplement, you're going to find the possible second solution. Now here's the catch on this. We have 180 degrees operating this problem twice. The possibility of it being a second solution, you find the supplement, but we also have to check if all the angles add up to 180, check to see if a third angle fits in the triangle. Sometimes you'll find that second angle, 180 minus the first solved angle, and then when you try to get a third angle, it won't fit into the triangle. There won't be enough space for there to be a supplement, okay? Okay, so let's go ahead and try some examples. All right, so when we do these problems, I'm going to draw my diagram. Notice that when I draw my diagram, I'm going to just draw over here, A, B, and C. And when I draw this here, I'm going to put 30 degrees here. I'm given little a is equal to 5, and little b is equal to 10. I still don't know a few information. I don't know the angle B, I don't know angle C, and I don't know side C. So I like to list which ones I'm looking for. So the measure of angle B, we're going to find that. We're going to find the measure of angle C, because we don't know that either. We're going to find little little c. Okay, so let's start off by doing what we know. We know that this angle and that side, so we're going to do law of sines to put sine of 30 degrees over 5 is equal to sine of b, the one that's opposite the other given side, over 10. Now I want to solve this for b, angle b, so I'm going to multiply by, in this case I'm going to multiply by 10 to get rid of this denominator. So the 10's cancel. Here I'm going to cancel these two and leave me with a 2. So 2 times sine of 30 degrees is equal to sine of b. Divide by, I'm going to go ahead and take the inverse sine of both sides. So the measure of angle b is going to be equal to this side here. I'm going to take the inverse sine of it. And when I do that, when I take the inverse sine of this value here, what I get when I do that inverse sine, I get 90 degrees. Now that's a sign that something different is happening, and that doesn't happen very often. So when I do this, if I get 90 degrees, be aware that I now have a right triangle. Other things apply. Now I'm going to do it just as if it were at any other angle, but you could set up, now use the Pythagorean theorem, because the Pythagorean theorem applies when you have a right angle. Or you could use the fact that this is now going to be a 30, 60, 90. But I'm going to assume that I don't notice that, so I'm going to go ahead and calculate what the measure of angle C is. You get that by doing 180 minus the given angle 30 degrees minus the 90 degrees, and that's going to give me 60 degrees. So measure of angle C is going to be 60 degrees. And then lastly, to find side C, I'm going to take, and I'm going to use the fact that you can do the reciprocal of the law of sines if you set up the ratio with the side over the sine of the angle, especially if I'm finding a side, that might be helpful. So I'm going to say C over sine of my angle, 60 degrees, is going to equal my given here, side 5 over sine of angle 30 degrees. Now I'm going to go ahead and multiply both sides by sine of 60. And that's going to give me C equal to 5 over sine of 30 degrees times the sine of 60 degrees. If I do that on a calculator, I actually get approximately 8.7, which would be rounded. Now be aware that if you notice that this is a 30, 60, 90, what you get as an exact answer is you could list this as 5 square roots of 3 if you want to. But that, again, if I'm doing the problem just as I would do other problems, 8.7 would be what I'd use to give a rounded answer. Now let's check a second case, the possibility for a second triangle. When I do this, remember, for a second triangle, I have to take the supplement of the solved angle, that first angle I have here. So the measure of angle here, the measure of angle B sub 2, because I'll say the possibility of a second angle B would be the supplement of that. So 180 minus 90 gives me right back to the 90 degrees, so that doesn't change the case. I don't have a second triangle. So check it to see if you do have a second triangle. We'll see that in this next case. So this case, we just have one answer, one set of angles and sides. For this one, we're going to go ahead and set up our triangle with ABC. So angle A is 30 degrees again. Little a is 5. Notice that we're going to put B as 7. So it's changed in this problem. We have B as 10. This is going to be 7. Let's see how this affects our problem. So I still need to find the measure of angle B. This will be my first case. Measure of angle C and little c. I'm going to find that in this information. So we're going to set up the law of sines. So I'm going to do sine of the angle, 30 degrees, over the side opposite at 5, equals sine of B over the side 7 here. Now I multiply by 7 on both sides to get rid of this denominator. And so what I get here is sine of B is equal to, I'm going to move it over to this side, and I've got sine of B equal to 7 times sine of 30 over 5. So I just have this side over here. Now I'm going to take the inverse sine of that. So angle B, the measure of angle B, is going to equal the inverse sine of this expression, 7 times sine of 30 degrees, all over 5. When I do that on the calculator, I get my value to be approximately here 44.4 degrees. So that's my first angle B here. Now I'll come back later to see if there's a second one. I'm going to finish this case first of all and find the other information. So let's find angle C. So measure of angle C is going to equal 180 minus the original 30 minus 44.4. If I calculate that, I get approximately, because I've already rounded, so this will be approximately 105.6 degrees. So angle C here is 105.6. Now let's find little c by doing our law of sines again. Since it's a sine, I'm going to put c over sine of 105.6 is going to equal my 5 over sine of 30, the original given. So go back to that instead of using the b's because those have been rounded. And now I multiply by sine of 30 on both sides, sine of 105.6. So c is going to equal 5 over sine of 30 times the sine of the denominator to get rid of it, 105.6. And so c, when I do that calculation, that will round to approximately 9.6 for an answer. So here I've got 9.6. Now that is my first solution. My second possible triangle here, so second triangle, I have to go back to this 44.4 and find its supplement. So the measure of the second possible B is the supplement of the first one. So 180 minus 44.4, that gives me, for an angle, that gives me 135.6. So let's go ahead and see if that plays out. So the measure of angle B, the second one, is 135.6. Let's find my possible measure of angles, the second angle C, and let's find the little c, the second c here to solve. All right, so for this, to find the second angle C, I'm going to do measure of angle C sub 2 is equal to 180 minus the original given 30 degrees minus this new B sub 2, 135.6, and that would give me, for a second angle here, that would give me 14.4 degrees. So 14.4 looks like it can fit another angle in there. So I've got the second triangle here. Now I've got to do the law of sines. Notice it's like doing a second problem here. I've got to find side C. So I'm going to do the same type of calculation here. C sub 2 over sine of angle C, which is 14.4 degrees, is going to equal my original here. I'm going to use, again, that 5 over sine 30, what's given to me, multiply by the sine of 14.4 on both sides, get out of the denominator. Now once I do that, I do that calculation, and what I get is about 2.5. So I do get a second triangle here solving. I get my first one doing my original case, check to see if the supplement of that original solved angle gives you a second case, and in this case it does. All right, lastly, let's try one here. As you could probably guess, we had one solution, we had two solutions. We're going to try one here that's going to give us no solutions. Let's see how that plays out. Notice that this side here is really short compared to that other side. So here's my triangle ABC. So 30 degrees. This is going to be A equal to 5, B equal to 20. And then we're going to find side C. And we're going to find measure of angle B. My first case, measure of angle C, we're going to check that. And we're going to find little side C. Okay, those are the three things missing from this triangle. Once we solve that, we see if there's a second case. All right, now we're going to do law of sines here. So I'm going to do again, I'm finding angle B next because that's opposite the side given. So I'm going to do sine of 30 degrees over 5 is going to equal sine of B over 20. Now we're going to go ahead and multiply by, in this case I'm going to multiply by 20 on both sides to get rid of that denominator. So I'm going to have sine of B, I'll write it on the side, sine of B, because these 20s cancel, equals this 20 times sine of 30 degrees over 5. Now, I'm going to go ahead and do this here. I'm going to go ahead and do this calculation, even though typically we do this next step. I'm going to write what I typically would do for the next step. Measure of angle B would be the inverse sine of this value here. I'm doing this whole thing in parentheses. So we do this 20 times sine of 30 degrees over 5. Now you would get, when you do this, you get an error. Now let's find out why. If you go back to this step and do that calculation, 20 times this, you're going to get 2. Why you get an error here is because sine of any angle, the largest it can be is 1. It's the domain for, or the range for sine goes from -1 to 1. It can't go all the way up to 2. So when you take the inverse sine of it, it gives an error. When you see that error, there are no solutions to this, so we have just no solution. So what we've done is we've expanded the law of sines to include the ambiguous case, which is side-side angle. That side-side angle could possibly give us one solution, two solutions, or no solutions, depending on what information is given to us. What you do is you go ahead and set up the law of sines to solve for that first angle that you find. If you get that you get an error with it, you get no solution. If you get that it's a right angle or some other possibility you know you have, or another value, you know you have a solution, and you just have to check to see what the supplement is, set up a second case, and see if you can work out a second triangle for the solution. Sometimes it will work, sometimes it won't. You just have to work through the steps to check that second possible solution to see if it works.